Alright, here's what we're going to start off with. It gives us the formula, which is quite nice of them. Okay. Now, what does it say about N? N is the amount of cane sugar initially present. Well, look, it tells us it's 75. So N is 75 is given to us right at the start. So okay. Now, what's X again?
The amount of dextrose.
Yeah. So the XDT is the amount of the dextrose sugar that's being the rate at which it's being created. Okay. And obviously, the more. So imagine I said 50 grams of dextrose sugar was created. That only leave 25 grams left of the other sugar that it's derived from. So it means as time goes on, its rate will get lower. Okay, that's what should happen. Okay, and at the very beginning, when X is 0, you have all 75 grams of the other sugar to convert. Right, so it should slow up over time. Now, so what we know is that at t equals 0, what can we say? T equals 0, X equals 0. That'd be a good way to start. Yeah. Okay, and then what else does it tell us? Alright, so we actually have two complete sets of limits. What will that yield when we go through the process?
The K value.
Exactly, it'll give us the K value outright. Because when you have two sets of limits, it'll give you the K value outright. So that's a good idea. Let's do that. So I think we're going for our log again, are we? Yes.
I'm just wondering, for these questions, should you use the time in hours or minutes, or does it matter? Because it gives it.
Yeah, do you see the way it varies in the last question? Yeah. I suppose I could just say that's t equals 90. Oh, so see the way it's a rate question?
Yeah.
So I suppose the rate would be grams per minute instead of grams per hour. So I think the answer would be similar. It's just different units.
If you do it in whichever units, it won't make a difference. Like, you won't get a wrong answer.
No, I wouldn't say so. No.
Okay.
It'll just be like, for example, is you get an answer of 10,
Yeah.
and that's grams per minute, while somebody else will get an answer of 600, and that'd be grams per hour. I think that's the only difference. Once you maybe specify your units, you'd be sorted, okay? I think that's the only thing that could probably happen to you there. I reckon I'm going to change that to 90 at the end, because I'm currently doing it in minutes. Connor, if you want to go for it in, just for argument's sake, do you want to go for it in hours?
Yeah, I'll do that.
And see, we'll convert our answers at the end, just to double verify what we're saying. Okay. Now, that's ln 75 minus x for me, and that and that will give me kt 30 and 0, and this is 6 and 0 on this side. Okay. That's going to be ln 69 minus ln 75.
Sir.
Yes, Mick.
Since you differentiate the inside of the bracket, is it a minus?
Oh, it is. Thank you, Mick. Thank you very much. Sorry, guys. Differentiate what's in the bracket, and this time it's a -1. Thanks for that. Okay. That'll make that minus ln, and it'll make the second one plus ln.
What do you mean differentiate the inside?
So when I have a, let's say, 1 over 3x squared minus 5, yeah? So it's ln what's underneath, but then you have to differentiate that as well. So in this case there'd be another 6x with it.
And so multiply.
There was another minus 1 with it.
Okay.
That's basically what happened there, and I just assume. So you have to be careful about that. Alright. It's the subtraction rule of, I was about to say it's the subtraction rule of logs, but I can probably just put the answer into my calculator and divide by 30. So it's ln 75 minus ln 69 all divided by 30. So, oh sorry, it's not 30t, it's 30k, because we know the t value. Connor, you should end up with a different k value as well, I believe, because if you're doing it in hours, the constant will be different as well. I got 0.14198. So where's my answer? Ah, there you go, a completely different answer to me. Interesting. I actually have exactly the same numbers they have. Let's try this one more time. ln 75, close bracket,
Yeah, I thought
minus,
so.
I think I did a bracket in there. Now we have the same answer they have. And we get that 2.77 10 to the minus 3. 2.77 what? 9, yeah. So essentially 2.8 by 10 to the minus 3.
If you went on using 2.7,
799, yeah, just say that and you'd be correct, yeah. Doesn't say anything about rounding off, does it? No. So whatever you want is correct. I'm just gonna just so I can keep up. I'm just gonna use the market scheme number, right? But you're not wrong. You'd be in fact more correct. Okay. All right, with you guys, the k value. Okay. Now. How much dextrose is in the solution after 1.5 hours? So I'm actually going to go back to this place here. See where we were a couple of lines ago? Okay, what if I change my k value to now? 0.00. 0.0028. Is that okay with you guys? Now, what does it want to know? The t values have changed, haven't they? So what's the t value for
0 to 90.
yeah, Connor, I think we should get exactly the same answer because it's how much grams is produced, isn't it?
Yeah.
So the k values are different, but I think our answer should be exactly the same. So we're going for 90, not 1 hours, because our k value is determined for minutes, not hours. Okay? And we start off at 0, don't we?
Yeah.
And we're looking for the x value. Like so. Is that okay with you guys? Now, what we're going to go for now. Same thing as last time. What Mick said was ln 75 minus x. Differentiate inside, so it's minus ln 75 minus x. And that's from x to 0. This is 0.0028t from 90 to 0. Okay, I think I can afford to come down a little bit here. Now, okay, minus ln 75 minus x plus ln 75 equals 0.0028 times 90. Ln 75 minus 75 over x. They really skip a lot of steps in that marking scheme. What's 90 times 0.0028?
0.252.
0.252.
Yeah, thanks. Alright. ln's log base e. Okay. Now we're going to go 75 minus x equals e to the power of what, lads?
0.252.
252. Right. Bring up the 75 minus x. Bring down the e to the minus 2.52. I'm thinking bring the x to the left and all of that to the right. I'm thinking we throw all that into the calculator.
Why'd you put 75 over?
1 sec, Mick. Matter.
You've
Yeah,
done the power
why'd you
wrong.
put-
I've done the power wrong. Okay,
put
thank you.
75 over?
It's 75
Oh!
just over e to the power.
Ah, yeah. Sorry, that's a fraction, isn't it? So, just as well as a maths error, because you would have just wrote down that answer and not even thinking, like. Is that okay? Let's try that again. $16.7? Did you get that, Connor?
Yeah, let's do 16.6 fine.
Yeah, yeah. That's perfect, guys. Another one bites the dust.